Testing, testing. 1, 2, 3. All right, let's get this party started. So I don't know if anyone can tell just by my voice, but I'm a little sick today, but it's fine. This is easy. I just gotta talk for like an hour. But yeah, yeah, just not feeling too hot. So if I miss any messages or whatchamacallit, forget things, I'm sorry. I'm trying, but I think it'll be fine because I have this set up pretty nicely. I will be taking like a quick moment to advertise just a little bit. Let's see. How should I say this? Yeah. Not feeling too good, but it's fan. VTubing's easy. At least it's easy once you get, everything set up. Like it's a little tricky to kind of get started, to get the model and figure out what you want to do. Maybe advertising. I'm not sure. Other stuff. But I think today will be fine. Yeah, because I'm a little excited, even though I'm a little under the weather, because I think I actually have some math stuff to kind of go over. All right, it's gonna be kind of like a test run, right? Because there's some features on this thing. Someone came by and used last time. We can take like screenshots and have things work out. So I'm gonna try to do that as well. There might be a little flickering in the beginning, but oh, what? I timed out. Uh-oh. Okay. Nope, this is fine. This is totally fine. 30 seconds. Yeah. Let's see. All right. So, yeah, last week I missed the stream because I made a mistake. I had a trip that I kind of forgot about. And I timed poorly my return flight. So, it was exactly right when I was trying to stream. So I'm like, oh man, well maybe I could at least, get some clips out. But what ended up happening instead was that I was just simply too busy. So last stream, almost like a ghost. No clips, just a archive of what happened. I thought it was interesting, and I wish I could have gotten a bit more of that. But it's fine. All right. So to get this party started, I need to finish up some stuff real quick because what I'm trying to do is figure something out. So I'm apologizing if there's a little bit of dead air. But I guess if you've been here long enough, it's kind of the thing that happens. And even if there is dead air, I tend to ramble and talk about nothing, so it still works out. Great even. Alright. There it is. So, last week, as I understand, was the first week of school for some people, and that's excellent. I'm so happy about that. Again, though, I kind of missed the boat, but at least I'm here for the second and or technically first week of school if you started on like a Friday or something last week. I don't know. So, again, I have to post my thing. If anyone finishes, otherwise today's lesson is, I'm not sure. Yeah. Let's do the spiel. So I gotta post this thing. So if anyone, hey, what's this guy all about? Chat. Ah, there it is, right up top. Alright, now what I'm gonna try to figure out is to see how do I get a screenshot. There's a feature here. And again, sorry if I seem like an old man, but I kinda am. Alright, is it insert? Paste from the web? Choose from your device? Well, I mean, everyone can see it though, right? So if I do this thing, then I think you're all gonna see all my files and stuff. Huh. Well, I didn't really think this through. Hold on. What if instead I copy paste? Let me try that. Let me go to this workbook. This here PDF. Let me zoom out a bit. So someone gave me a brilliant idea to work on some weirdly complex stuff, where you have to figure out algebraic equations for like expressions for like weird funky shapes. So let's give it a try. Alright. Copy. Now the nice thing about being a low view VTuber is that you can make a lot of mistakes early. Oh, I forgot. My yeah, it's my mute button. Whoopsie daisy. Just mistakes like that. You can make mistakes and it's totally fine. Mistakes. Uh-oh. I don't know what I copied last. Oh, it worked! Hey! Alright, how do I move this thing? Oh, look at that. That actual math. Wow. Okay. Alright, this may or may not be a bootleg math textbook, right? So please bear with me. But I'm trying. There it is. Simplifying algebraic expressions. Alright, so this funky thing. Okay, so they're using words like communicative, distributive, and all that kind of stuff. But basically what you have to kind of put it as, am I moving the whole screen? I am, cool. Is that 1 equals 1 in a nutshell, right? When you look at algebra, this is basically what it's all about. If you have 1 equals 1, then there you go. And the reason why I say that is because if you do it to one side, you just do it to the other, right? So you do plus x here, then you gotta do plus x here so it can still be the same. Now, of course, they're not gonna give you equations like easy like this. They're gonna give you some funky stuff. So let's work with that. And it looks like they kind of give you the... And what are they solving for? Yeah, okay, I see. So it's 3x minus... Whoopsie daisy. I'm going to start with this one. 3x minus 2y. And I know the answer is right there, right? But it's one thing to just stare at something. That's another thing to actually kind of like look and talk about it. It's like art, right? If you have like go to a museum and there's like a really nice painting, you're like, oh, that's nice, right? But then if someone who knows about the painting says like, oh yeah, this guy made this on his deathbed as he was screaming heavy metal lyrics and painted it with his own blood, you're just like, whoa, that's so metal. Right? Or something crazy like that. I don't know. But with a lot of PDF and online textbooks, especially if it's open notebook, sometimes you're just going to give in the answer, but it doesn't really stick. You're just kind of eyeballing it. You're like, okay, I just copy what they do. All right, I'm done. I just kind of, copy paste here without really paying attention. And, that's a useful skill in and of itself, like as if you're working on a giant data entry, right? You don't really need to have some kind of in-depth insight as to what you're doing. You can kind of just, do something like this. Copy the piece of here. There you go. Do that for however many hours and you get paid. not that much, but it's a job. But that's not what I'm trying to do, right? I'm not trying to get it twisted and say this is, you know, this is what math you should learn from math. It's just copy pasting. Rather, let's try to understand what is this and why is it important, or rather, how does it work? Why does it make sense? And more ideally, right? Why would anyone do this? Why is it important to have all these x's and y's and try to figure things out like that? Well, I'll get to that in a bit, but let's just put this work together. So, yeah, what they're doing here, if I could zoom in a bit. Oh, that's so cool. I like this. All right, is that here's the full equation as it was given, right? But because there's no parentheses, because there's no funny business, it's just kind of all there, right? And if you have the symbol, that's basically like it's, whether it's positive or negative or it's charged. So it carries and it sticks with it right there. I know, maybe a little obvious, but the thing is that, you know, when you switch over the x, it's not like minus x, because the x is positive. It's minus 2y. So even if you put the y in the back, it's still minus 2y. Now, the reason why they do that, and as a visual example, is not just because it's a rule, right? And not just because it makes common sense. Let's say, for example, you have, oh geez, what's an example that's not money? You have oh, football. Oh yeah, football's great. All right, so you got football, right? And well, American football. European football is cool too. I just wish I knew more about it. All right, so you got like this field, right? And then there is, you know, sometimes you go forward and you make some plays. Sometimes you lose some yardage. Sometimes you go forward again. You go back and forth, right? Now, even though you're going back and forth, right? This is still a net negative, right? Without these net negatives, right there, with those little arrows, what would happen is that, and again, this might be a little obvious, all the positive directions would line up, and you would have made like a field goal, or touchdown, sorry. You would have made a touchdown like minutes earlier, right? So those lost yardage actually has an effect. Now, when looking at something like algebra, right, that's kind of the same idea, where you know, this negative value sticks to the number because these are basically lost yardage in this equation, and you know, these positive numbers are basically gain yards. Why is this important? Well, maybe it's because of something like someone wants to do formulas, right, for a casting, and just say, oh yeah, this guy lost X amount of yards, and this game, and it was terrible. He just kept fumbling the ball. He kept getting tackled. It was just awful, right? But in order to make that critique, they have to have the idea not only just visually that this person is losing yardage, but you could also do it formulaically, because after the fact, right? I'm not quite like Moneyball, but something similar. You can look at a player's stats after the fact, after the game, and kind of see, okay, here are the raw numbers of where they failed and where they succeeded, right? Here's where they gained and here's where they lost. And those will probably be in something similar like this, because they'll think, well, what is the factor? What is this y? What is this x that helped him gain? What is this y that made him lose? Was the y specifically this one linebacker that was weak, and he's causing everyone, and if I plug in this thing, he's like causing everyone to lose yardage no matter who our quarterback is? Is the x, you know, the reason why he did gain is because he's decided to just start running the ball, right, instead of throwing it, and they had like a weak defense that couldn't, you know, deal with that. And so again, these buckets of values, these x's and y's, yeah, seems boring, right? But it has very practical applications if you really want to analyze something like your favorite pastimes, sports, money. That's money really is easy, but I'm trying to do something other than that. All right. Now here though is a little bit different, right? Because you might think, okay, well, yeah, that's cool and all. That, you know, you can have this formula, right? But what's the point? Why do I even need this formula, right? Well, hold on. Sorry. Let me backtrack a little bit. You might be wondering why you would need it in a formula version, right? Why would you not just have it in just straight simple numbers? And that's the thing, right? You have to go play by play by play, right? Maybe this was first down. Maybe this was second down. Maybe this was third down. Here's fourth. Or maybe they got some yardage on this X, so they go back to first again. Actually, wait, that doesn't make sense. It'd have to be like this. Sorry. It'd be first down, right? And then it'd be first down again, because 3x is definitely greater than x. So if you're able to get, you know, 10 yards on x, for sure, then 3x is 3 times that amount. Yeah, like 30 yards. Insane. Alright, but then you lost some yardage. Now it's second down, right? But it's 2y, and maybe you didn't make up that distance. Maybe you lost greater than 10 yards. Then you got third, and then you got fourth, and things are just terrible. So you can actually go and look at each play by play by play, plug in these numbers, right? Try to figure out, okay, what is the variable that is causing these gains and losses? And you might not even just use x and y's, right? Maybe you could use a different one for each, because maybe you could see clearly, like, oh, okay, yeah, x is when he was able to actually do a pass. So x is pass. But then these two y's, they might be in this example, right? They're the same. And so this is when he got sacked. No, yeah, let's make it worse. Let's make him fumble. But it's not a turnover. It's just a fumble. Alright, and then you got this mysterious value here if you think winner is just like, it was just a bad play. So, in this example, right, if you ever want to look at sports, if you ever... I hear sports betting is popular. I don't know how true that is, but to that end, right, they have formulas for that. It's not exactly algebraic like this. It's usually derivatives. Ugh, derivatives. It's so hard. But, you know, they'd have something to kind of analyze plays and players and stats and, you know, environments and all the other factors, right, to moneyball it. So how do we simplify this, though? Even though we got all this data, right, this massive data sheet, it looks like this horrible equation. Where do we go from here? Well, and then that's where you kind of use some of this algebra stuff, where you kind of combine like things, right? You're going to scoot this plus x over here, you're going to scoot this negative 3y over here, and because 7's by itself, you're just going to leave it. Now, technically, you could kind of do these in almost any order, right? You could do y, x, and then number. You can do number, y, x, whatever combination you want, right? But typically, the way that is kind of easiest to solve and do these things is you want to have it x, y, and then number. Because they like to add extra numbers when you get into the higher level maths. So they're going to start, you know, saying, okay, now it's just not x and y, it's going to be x, y, and z. You're like, oh man, okay. And then you got the number. Great, now you got like 3 variables. And then it could just keep going on and on and on, right? But if you have a consistent formula where things are alphabetical, then it's easier to work with. It's just kind of something you don't have to really memorize. It's just, okay, that makes sense. You got the letters, and then you got the numbers, and the letters in alphabetical order. Sure. So you could just, you know, if you get like a test that says like F, G, and H, you could work with that as is. But they probably want you to have it in like alphabetical order, which, wait. That is in alphabetical order. Oh, man. Yeah, well, there you go. Then it's already there for you. But if you want to rewrite, I just don't recommend it. Alright, so, now to go to this one example, once again, alright, let's scooch everything together. So you got 3x, and then you scoot the plus 3, or sorry, you got 3x, and you got the plus x, so you do that there, and then you got the y's. You could do the bigger number, the smaller number. The weird thing is that because they're negatives, actually -2 is the larger number. Because, you know, you're a bigger person if you're only missing, like, I don't know, 2 pounds than if you're missing, like, 3 pounds. So there's that. So the smaller negative number is larger than the larger negative number. That's the nice thing about negatives. They're so weird. And then when you kind of do the math with, like, fractions, or like yeah, there we go. We got some fractions there. All right, we'll check those out in a bit. It's a little funky. All right, so this is, I guess, called the communicative property. I don't know, but there it is. And the thing is that you can actually add these together. Now, why are we moving them together? It's because you actually can't combine y and x, or just a number and y. Those don't really work. And the reason why those don't work is because this variable, it could be literally anything. It is a bucket to store value, right? So let's say, for example, if you have, I don't know, -3y minus 7. So if you're looking at -3y minus 7, you're like, alright, well, why don't I just minus the 7, and then it's just like maybe, I don't know, -10y. Because y could be 0. And if it's 0, then you should actually just have -7. It could also be 1, and then you'd actually be correct. But then it could also be like 100, and then you'd be way off, right? So these things are just buckets. You don't really want to combine them. And I didn't need to erase that. I'll just leave it there. Whoopsie daisy. So you want to kind of keep them separate and identifiable. Kind of squish it together so it's easier to read. So instead of having this big mess, I can simplify it where, you know, 3 plus x, or 3x plus x, it has like this phantom 1, you know, just kind of how you think of, like, alright, how many smiley faces are in this picture? Well, there's only 1. But how can you tell? There's no number 1 next to it. Well, I can just count. I'm looking at it. There's only 1 smiley face. Yeah, that's kind of the same logic here. There's like this phantom 1 that's by every variable, where, you know, and the 3 would tell you how many of those things there are, right? But if you just have the thing by itself, you only got to eyeball it and just say, like, yeah, there it is. So, to that end, right, what's basically 3x plus 1x? It's 4x. Alright, and then what's -2y minus 3y? It's like adding, but backwards. So you get -5y. And then you just kind of have the 7 still there by itself, and it can't do anything. Now, I'm pretty sure that's the answer. I haven't looked at it in, like, I don't know, 5-10 minutes. 4x minus 5y equals, yeah. Ah, there we go. Good enough. Right? And again, I know this was a very, very kind of long and windy way to kind of get to the point, talking about football, talking about negative values and smiley faces. But the point is that, you know, I'm not here to do homework that doesn't exist, right? I'm just here to kind of teach greater concepts that will help you succeed when you actually do get to do it. But if you do have homework that does exist, right? Just feel free to say something in the chat, and we can get something started, and I can help you out directly with whatever you got for free. I'm doing this for fun. That's why I'm doing it while I'm sick. You know, like how people well, I shouldn't say people. Like when I'm sick, right? And I take a day off or something. I'm like, oh man, I feel awful. Oh, this is terrible. But then I'm somehow able to squeeze in like a video game or two, you know, or a bit of reading. Same thing. Right? Yeah, I'm sick, but I'm doing this all for fun, so it doesn't matter. Alright, so here, distributive property. And, ooh, is there a way to copy this and make it bigger? I wonder. Hold on. If I try to copy this, no, it only copies that. Ah, nuts. Okay, I have to, I guess, write it. So what's it? Well, hold on. I have an idea. Alright, let me try. 2r minus 5 parentheses 3 minus r parentheses plus 4. Alright, if I copy this, right, or I highlight it, Oh, there it is. There it is. I can make it big. Oh, wait, hold on. I don't want to make it too big. I didn't zoom out yet. Okay. Alright. Let's move it this way. Alright. So distributive property. Again, they're using different variables. That's totally fine, right? You could use whatever you want. I'm a fan of just using smiley face because it's so ridiculous. They don't do it enough in school. But with things like R's, you know, in terms of just a variable that you can use, go nuts. In your mind, right? And in personal accounting, maybe. But if they have like homework, you can't just like change their variable in the middle of it. No, you can't just switch it for like A, because then that confuses the teacher. Even though you might know what it is, they don't. So, and that's kind of the thing about like homework and math stuff, right? It's not about getting the right answer. It's just kind of showing the teacher what you know and what you don't know. And if you show enough that you don't know something, then that's kind of evidence to say like, hey, teach, you're going a little too fast. No one's caught up yet, right? Chill. Can we get some extra focus on this part, please? It might not work, right? If you're in high school, but if you're community college, hey, there's a lot of chill teachers. Unless they're substitutes, then I mean they could be chill too. They can actually be supremely chill, right? But they might not have the mastery of the material required to kind of pace at a custom level rather than just following someone else's game plan. Alright, that's enough commentary. So, distributive, well, I mean, then again, this whole thing is commentary, right? I like numbers and homework. So, never mind. More commentary. Okay, so let's do this. Now, when you have a 5 next to parentheses, again, might be kind of obvious, but if this is all new to you, cool. Now, I'm glad I could help out. Right? Let's just change it to something else. Let's do smiley face minus sad face. Right? And let's just do... Ooh, what goes well with these things? I got it. This symbol. Okay. No, wait, hold on. That's not how it works. How do I do, I gotta do sideways emojis. Yeah. Okay. Check this out. So, let's do this symbol. Right now, this is actually a symbol to use greater or less than, right? So don't do this example. I'm just doing this because it's silly, and I like silly. Alright, let's do colon, smiley face. Let's do colon, angry face, right? Now, you have this little part here. It's not a 7. It looks like a 7, right? I should try draw it better, because I draw my 7s with that little tail on it. That symbol. Okay. Now, how does this work? Right, you got these emojis, and it doesn't really make sense. I'll get into the purpose of this in a bit, but just for now, just to show how it works. What you're going to do is, when you have something multiplied to an equation, right, you can actually break it into those. Because, once again, right, if you have 1 equals 1, right, and you multiply the whole thing by, like, infinity. Well, how do you do that? What you gotta do is, well, actually, no, it wouldn't be in parentheses like that. No, it would be, I think. Yeah, because you could have equals, you could have whatever equation you want in the middle. You can even have, like, a equals less than, greater than. Although that doesn't make sense because they're both 1. Alright, so 1 equals 1. Cool. Well, you have infinity, right? And if you put 2 things next to each other, they're actually multiplied. So going back to here, right? When you have this 3x, that means there's 3 x's. It actually looks like this, right? There's 3 of them. And then you have plus x. This is kind of like a visual example of what you got going here. So it's not just like the number 3 and the x. There's actually like 3 of these things in this space, but they condense it and they mush it to make it look like the number 3. And then when you count all of them, then they condense that to make it to the number 4. Makes sense, yeah? So to that end, when you have something next to something, right, this is a bit weird because this symbol is next to this whole equation. How do you do that? Well, it's easy. You just kind of give it to both sides. All sides within. Now, I think I've made a bit of a logic jump, so let me try to work backwards a bit. If you have 3 multiplied by x, right? Plus 1 multiplied by x. The equation would look something like this, right? And the reason why it's kind of in these bubbles is because, just again, 3x is a representation of 3 little x's together, right? But you can also take the 3 outside, and the reason why it looks like this is because the intermediary step is to condense all the x's and say, well, there's 3 of them. So we could just take this 3 outside. Now, just like how you could count all the 3's, 1, 2, 3, and take that number and move it outside in this example to get to here, you can also put it back in, right? So then you could also be saying 3x with a bubble equals 3x without the bubble. However, this does change when there's actually an equation within that little bubble, right? And an example would be something like this, where let's say you have a bubble x, x, x plus x, right? And let's do a new number. Let's do 4, right? Well, you have 3 x's here, and you have 1 x here, right? But they're all kind of the same numbers, so you can combine it. It can be nice and easy, right? You have 1, 2, 3 x's, so 3 plus 1 is, well, okay, technically, if you have variables that are all different, it might not look like this. I forgot. So what this is that this actually, with the 3 x's, is a different notation. What it should be x plus x plus x plus x. And these are in the bubble. And this whole thing's in the bubble. And the reason why is because, again, I totally forgot, and I'm sorry, that if you have things touching each other, they're multiplied. So this is actually x times x times x, aka x cubed plus x. And that would be a different equation than having x plus x plus x plus x. So, my bad. Let me just do away with this, and we'll pretend it never happened. Alright, but we're still putting the 4 back. So, you have 4 here, and then you have x plus x plus x plus x. And you can add them all up, and then you have 4... Well, let me scoot this a bit so it's easier to see. Then you have 4x times 4, right? And the weird thing is that because it's the total number of x's, then you just do 4 times 4 and you get 16x. Now what can be a little confusing is because I said for the other one you would distribute it, right? So why wouldn't you do it like this? Why wouldn't you do 4 times 4 and then times 4 times x, right? And then you have like 16 times 4x, and then that's something totally different. No. The reason why is because if you eyeball it, this 4x is, again, representative of all these x's plus together, right? It's not just there's an extra x that's here. This x right here is representative of the total number of x's. It's not its own separate thing, because these are already multiplied together. So, to that end, another way you could also do it, which is a bit more brute forcey, is you have x, and you know what, we can even break the inner bubble, even, because it's all being added. Not a very good habit to start breaking parentheses and bubbles when you're doing math, but this is my show. I'll do what I want. Okay. No, the reason why is because generally there might be something with like divisions or fractions or some kind of multiplication. If it's if there's exponents, if there's multiplication, division, or some other funkiness like derivatives, then you don't want to start breaking bubbles. But if everything's pluses and minuses and you're just adding and subtracting, you could kind of shatter them willy-nilly. In fact, I think one of the earlier math things that you might have learned is, you know, if you have minus -2, you know, what does that equal? Well, you want to actually break the bubble. You can do the -1 times minus 2, and it equals 2, aka positive 2. And so when it comes to addition and subtraction, you actually want to break the bubbles to get your answer. So in this way, you know, we'll break that inner bubble. That was right here. Alright. Let me do it like this. Okay. Now, you can also distribute the 4 this way, right? You can do it to one of each of these. Because there's 4 x's here, 4 x's there, 4 x's there, and 4 x's there. And then what you have is you have 4x plus 4x plus 4x plus 4x. Ah, look at that. Look at that glorious penmanship. Gotta love it. Alright. So, again, because we're multiplying into it, we actually do break the bubble. So now this whole thing's in there because we put the 4 inside. But we don't need the parentheses anymore. Alright, and again, these 4 x's are now representative of 4 of these little guys. So what do you do next? Yeah, you just add them. So you do 4 plus 4 plus 4 plus 4. 16x. And that should be the same answer. Ah, there it is, 16x. That's when we do it the shorter way, right? So this is the longer, more visual way. This is kind of the shorthand way. Now, assuming that this principle is correct, right? That you can just move things. And this is incorrect. And this is incorrect. But this is. You can even do that when things are a little funky and they don't seem to make a lot of sense. So, to that end, you can have infinity go into these different things. It pops a bubble when you have infinity equals infinity, right? To that end, you know, you can have this number, because it's not being added, it's not being minused, it's not being divided, because if it was, it'd look like this. When it's next to it and touching it like that, then that means it's being multiplied. Again, as a symbol, right? This. There are symbols where, you know, this means greater than or equal to. There's this symbol which means greater than. There's this symbol which means something else. Right? I'm just doing this as a silly emoji symbol, not as like a mathematical symbol. So I could have this thing pay off. Check it out. And then in that way, you have this face minus this face. There. Now, even if it wasn't the symbol, right, and it was just the number 7, which would make even more sense and be less confusing, it would look weird like that, but, I mean, the math still works out. No matter what this thing is, right, it could be a complete mystery box. Whatever it touches and it gets multiplied to, you can divide into the things within it, because it's being multiplied with those parentheses, right? So, going back to here, really long way to do it. You have 5 being multiplied by 3 and r. So once again, you do it like this. Now, there is a bit of a trick to this though, because it's not just 5, right? The symbols carry with it. It's negative 5. So, you have in the front 2r, right? But what is negative 5? And this is an assumed positive 3 because there's no symbol in front of it, times 3. Well, that's negative 15. And what is negative 5 times negative r? Well, that's positive 5r. And you got the plus 4 at the tail end, right? So you pop the bubble, you distributed the negative 5 into the inner equations, and so this symbol flips to negative, and this symbol, 2 negatives, make the positive. And once again, you can kind of group them up. So you got 2r plus 5r minus 15 plus 4. And again, these are representative of the numbers. There's like a bunch of r's here. And here's a bunch of r's here. 1, 2, 3, 4, 5. There you go. So then if you add up all the r's that are already added up partially, then you get a total of 7r. And then if you add a number to a negative number, it shrinks it and brings it closer to 0. So you get negative 11. Now, I have 7r minus 11. Let's see if that's right. Could be wrong. Nope. Hey, there it is. Alright, now these other things, it looks like they're kind of the same equations. They just have different variables within, right? And what I mean by that is that, you know, you still have the variables t, s, and stuff like that, but the variation is actually in having it being like fractions. Let's see. And this one looks like they have weird combos where you have mn, and it is separate from m and n. So the reason why is because, again, let's say, for example, if n is 0 and m is 100, right? You know, 5 times 100 times 0 is 0. This would be 0, but this would be 500. And so if you kind of think in that way, if any of these numbers could be 0, you would see that they don't actually combine easily, because then the total value would be negative 500. But here, again, assuming n is 0 and m is 100. But if you were to just combine these two together, let me zoom in a bit more. If you just, oh, did I move it? If you were to combine these two together, then you would have 5mn minus 5mn, and then that'd cancel out to 0 total. Well, not divided by. Equals 0. Which again, is not quite the answer. 0 does not equal negative 500. And these equations, the reason why they have them in this format is because these variables should work and simplify into this equation no matter what the variables within are. They could be any number at all, but it should still make sense, and this equation should still function equal to this. So it's just kind of simplifying, right? Now for the fractions, I could do that, but I'm actually feeling a little more sick, so I don't know if I want to. But would it help? I don't know. If it would help you, just please say something. Otherwise, I think I might look towards something else, because I think this subject I've already beaten with a stick, and it kind of makes sense. Oh. Yeah, this funky thing. Alright. So, this weird funky shape, right? These designs, I believe, are actually these equations. Wherein, if you put, and that's the nice thing about this kind of level of algebra, right? Where, I don't know what, let's do like a graph, right? Let's do this design and this teardrop looking one. This blob looking one, and this brontosaurus belly looking one. Alright. So these are actually as cool as they might look like. You think, oh wow, that's abstract art. What does this have to do with anything? Well, actually, I don't know where the exact equations are, but these weird, funky, abstract art shapes are actually mathematical equations. In that, let's say, for example, there is like a limit, right? Where if you put in any value beyond these limits for each of these shapes. So let's look at this teardrop one, right? If any value is below, what's the halfway point? Let's see, this is 8 centimeters wide. This is 32 centimeters. Okay. So here's the length, 32 centimeters, right? And so half of that, which I assume is this halfway point, it'd be 16 centimeters and 16. Now, you don't have to take notes on this, right? This is just kind of something I kind of want to, I think is interesting. But if you put it in something like a grid shape, where it could be either in the square middle, but it more, actually probably be more something like this, right? Like a graph, where you have x and you have y, and some point here at point 16 to point 32, because if we're counting from left to right, and here's 0, you have this shape. Alright. And then let's say the whole height of this thing Oh, no, wait, no, it doesn't go all the way to the end. Sorry. If it did, it would look like this, actually. That would go all the way to 32. So let me try to draw that again. It's more like right here. And we can call this point that we don't know X. Aha! Putting the dots together. Right? And so, if you have a point of X that is an unknown value where you don't know what this number is right here to where it goes to, that would be your X. Similarly, this thing doesn't actually go all the way to the bottom of Y, but assuming it did, or no, it's not. Let's not assume. Let's clean this up. All right. So this bottom point where it's touching is actually a Y value, and we could call this Y1. We could call this point up here Y2. We could call this X2. We could call this point X1, even though it really looks like it's 16. We'll just call it, like, because it looks like it goes like right up to here, but there's that little divot, so maybe it actually is. So we'll just call it X1 for now, just to be safe, right? And then, let's see. It goes up to 24, so you have all these extra spaces where here's 0, and here's 24. So I'm a little out of the way. There we go. That should be easier to see. And so to that end, right, you can actually have a formula where you have, let's see. What would it be? I don't know. I don't think it'd be like minus. It could be like divided by. It's not added. Is it minus? Sorry, I'm trying to think. Would it be something like this? Y2 minus Y1 plus X2 minus X1 equals area. Because it's in the area in between Y2 and Y1. So I assume it's minus, but I could be wrong. Maybe it's just... But it wouldn't be add either. But if it would, then that means that these would have to be like some kind of... oh my goodness. What am I saying? Y1... Yeah, no, it's a smaller number that has to be minus. Okay, so this kind of makes sense. Again, could be wrong. Doing this totally off the cuff, right? This whole other part was easier to explain because it actually had samples. But I always struggle a bit when I'm trying to make up equations for things that don't exist, and I always think, is it a logarithmic function? And like, am I going crazy? Is it do I need exponents? Is it derivatives all over again? It might be, right? Because this is in the area within a yeah, it might. Oh, jeez, I don't want it to be. All right. Well, anyways, putting that mess aside, right? Of what this answer actually is. The point that I'm trying to get to is that there is a mathematical equation that exists, maybe somewhere else in the textbook, that shows you the exact area, and if you put in any number, right, in this equation right here, or a similar equation that actually works, then if you put in like 100, if you put in like 40, then it won't, 40, if you put in like 4, then it will either be a hit and color in the area within the circle, or it will be a miss and it won't color in anything at all. And so you can actually break down, you can build images from mathematical equations, but you can also break down images into mathematical equations as well. To that end, that's kind of how, well, I don't know if it's exactly how, but it's similar to how I understand AI might be working, where then they use mathematical equations to decide to figure out which portion to color, how much to color it in, shading and all that kind of stuff, right? There's a lot of crazy things can be broken down into numbers. It's like really weird, the connection between like music and math, art and math, and how they can be like formulaic, but also they're formulas because they exist in a state in which we like to understand formulas naturally. So, to that end, right? Even if you have this crazy, funky painting that you say it means nothing and no one can solve it, right? It is the anguish in your inner soul or whatever. The dark miasma cloud, right? Here you go, masterpiece, boom. Someone could probably, you know, break this down into an extremely complex, but actual, like, formula to say, okay, the seconds in which you were drawing this thing, it actually curves in a very specific way to make this kind of shape, and then it goes here, and then it goes there. And it can actually be, like, computated into an actual thing, which is wild to think about, right? And the reason why no one does it is because usually it's kind of a waste of time. But let's say, for example, if you are an aspiring artist, right? Math may help you in that. Let's say, for example, you want to draw a drawing down the road, right? How do you do that? How do you draw distance? Well, you can actually draw triangles. Like, let's see, trigonometry triangles. Something like this, right? Right. So here's a triangle. Here's the midline. Right. Here's a telephone pole. And it just goes off into the distance like that, right? I'm not drawing it very well, but, like, you know, just, you know, theater of the mind. Let's see, does this look like a telephone pole? That looks like a pitchfork. Yeah, I think they're supposed to be more, like, rounded on the top. And, like, touching the actual wire. Something like this, I guess. Yeah, okay. Good enough. Alright, and then if you want to draw birds, you could draw, like, little V's. Right? Faraway birds. Cool. There you go. Yeah, you have a drawing. Oh yeah, there's the horizon. I forgot. Probably like a sunset. Let's do midday sun. There you go. Art piece, right? Now, a lot of these things, these lines that I use to kind of give the illusion of a road and a distance and little things, they can be, again, a formula. Here's the midpoint, right? You get whatever the length this is, x, you divide it by 2, and you draw the line there. That's your horizon. Right? You have this line right here. No, wait, hold on. This is a y. Whoopsie daisy. Y divided by 2. That's your horizon. And then here you have your x. You divide it by 2. Whatever the size of your canvas or piece may be, and then that's your, you know, stripe line to was it the center, to the center divide or something? I'm sorry, I forgot what these things are called. It's been a while. And then again, just like with every line, every stroke, every kind of piece that you put into this art, you could make the skeleton of it, the basis, the symmetry of it, using formulas. Right? Even if you want to do something funky, right? Even if you don't want to have it centered in that. You're doing something like a movie, right? And you have like these 3 frames. And then you want to have the audience attention over here. And then you have something that like guides their attention towards that point from here and here. In that way, you know, if you have someone like pointing. Oh no. Oh wait, why is his hand like an arrow? It's pointing that way, right? And then you have a character that's like sitting down. And their line of sight is facing that way, right? And then you have like a plant in the corner. Does this look like a cactus? Yeah, it's good enough. Yeah, it looks like a spaceship cactus finger thing. Maybe this will help. Right? And by having all these things within your frame of your art piece, you're able to kind of guide the audience's attention towards whatever it is, that thing that you want everyone looking at. Let me clean that up. There you go. So, to that end, right, could this be a formula, right? Within every 5 minutes, have people look to the left. Or no, this is the right. Man, I am way out of it. I'm sorry. Every 5 minutes, people look right to see the thing in the corner in the shadow, because it's always hanging out on the right side of the frame for some reason, right? And you can kind of break that down, and then you could also figure out a formula for saying, okay, well, at this point you need to rotate the camera around the scene, so then, you know, it's always kind of, even if this thing is moving and prowling, you know, it's always on that side of the frame, so then people are always kind of looking that way, like a spiral. And you don't see that as a spiral. To your eyes, it's comfortable because it looks like it's off to the corner, but to the camera and the room moving, it's in a spiral, right? There's a lot of weird, and again, I say formula in a very loose term, right? This isn't like a hard math, you know, you have to do this every 5 seconds kind of thing. It can be though, right? You can have an extremely formulaic, very center frame piece. I forgot who is that director that liked to have everything like center frame and perfectly symmetrical. But, you know, there's a formula to that filmmaking technique and finding the right angles and the lighting and stuff like that, right? To that end, the point is that in this example, yes, math can be weird, right? It can have X's and Y's, and maybe you don't think it's a lot of fun. But if used properly, it can be used to apply to things like, you know, figuring out someone's football stats to figure out if they're, you know, the player that you need or the player that you don't need, right? And it uses a lot of shorthand properties for you to be able to understand how these numbers can combine or break apart. And also, algebra can be used to kind of make lovely art pieces. There we go. That's today's lesson. Cool. So again, if anyone needs help with any specific homework or any specific formulas, yeah, just please let me know. Say anytime in chat. But otherwise, I'm going to keep doing this thing where I kind of give lessons on how to apply maybe the lesser appreciated aspects of homework and math and school into a practical real-world applications for your enjoyment. And for mine too. This is fun. And with that, oh, thank goodness. I'm sick as a dog. Alright, I'm gonna log out for the night. But hey, to anyone that stayed by, I want to thank you very much for coming. Again, sorry about last week. I was just really busy on a trip. So I totally missed time all the time. My VOD expired, like everything was gone. So, but this time I'll work to get everything up and saved. And until next week, I'll see y'all later. Oh, also, if anyone wants weekend tutoring, if you stumble upon this and you find weekend tutoring works with your schedule, right? Friday nights, Saturdays, Sundays, anytime during the day or night. Ideally Pacific Standard Time, but I mean, yeah, I can work with your time zone. Please let me know. Right, you could send me a DM on Instagram. You could send me a DM on Twitch. I'm on those platforms, so let me know and I'll try to work something out with you. Because this thing's a lot more fun to be tutoring when there's like, you know, someone to tutor. Alright, until next time. Have a good night, everyone.